Good evening, everyone. So I hope everyone had a good dinner.
Come in. Wait. Notifying. So when got numbers here, it's like people come in. Hello. Say hello.
Okay, good evening, everyone. I hope everyone had a good dinner today. So I had quite a lot of people who is saying hi to Teacher Chiu. Alright, I call myself Teacher Chiu, alright, so not Teacher Chiu because a lot of people call me Teacher Chiu, then they speak faster, right, then Teacher Chiu, then at the end it becomes Teacher Chiu, yeah, so, hopefully everyone had a good dinner. We will begin in 5 minutes time. So, how's everyone? Anyone want to speak to me or anything? Hi Mike C, how are you doing? Yeah, all's good. Alright, so today's question's a little bit on the tough side, so I hope everyone is ready. Teacher Chiu will do his best to explain and make sure everyone understands what is going on. Let's see. Well, we have quite a lot of people who are joining in. We have around like 11 people now. That's pretty fast. Okay, let's see. Hi, Brandon. Hi, Hashing Tom. When is RIPMWC? RIPMWC will be expected to be starting at the end of March, right? Your school should be sending out invitations to your students already. It's invitation only. So, schools are going to select students to represent them. So, you might want to contact your school for further details. Yep. Okay, so we have 13 participants now. Just feel free to talk to me anything under the sun. So maybe I'll share a little bit about myself first, but I guess. Alright, so I've been with the tuition industry for roughly maybe say 5 to 6 years already. Yeah, so I've been teaching from PSLE all the way to A levels math. It was quite interesting for me to actually experience all these MO questions. All these MO questions, right, I noticed, right, some of them actually use quite a bit of A-level and O-level concepts. Yeah, so I was actually really surprised that some students, right, some primary school students can actually do these kind of questions. Yeah, so yeah, hopefully everyone can be like these students also, after learning all these concepts today. And do well for RIPMWC that's coming up. Yep, hi Angel. Hi Angel baby. Right. Anyone has any questions about Teacher Chiu? Anyone? No one? Oh, okay, it's quite a bunch here. Alright, we have 11 participants right now. Let's see. Okay, so we have 2 minutes before we start. Alright, we will start at 8 p.m. sharp. Alright, we'll go through all the questions. We have roughly six or seven. Seven. I think we got 7 questions today. Yeah, we got 7 questions today. We will try. It's going to be hopefully everyone can learn something out of it. How do you select your students? Well, usually most of the time they'll select based on the scores of the students. Yeah, so usually when they select students for competition, right? Last time they will always look at your end of year results. Yeah, they will look at your end of year results, your CAs. But of course, your CAs are now cancelled, right? Most of your CAs are cancelled now. So I'm not really sure how are they going to select, but you can be assured that it's going to be based on scores, right? They're going to order the students. They will pick the top 20, top 10 students, and they will invite them and then send them over to RI and do RIPMWC. Yeah, so that's the general rule of time for students, especially for schools with limited number of seats available. Yeah. Okay, so 1 more minute. Alright, so I'll begin shortly. We have around 12, 14. Hey, not bad, we got 14. Alright, we got 14 participants now. Alright, we'll start very, very soon. I hope everyone is ready. Okay, just a little bit more, alright. Hey, wow, that was a big influx of students. We have around 25 students now. Wow. We have around 25 participants. Maybe not students, but 25 participants now. Oh, that's a lot. Alright, so it's 8 p.m. now. So I hope everyone is ready. I hope everyone has obtained the DMD Week 1 paper from our WhatsApp group. If you are still not in our WhatsApp group yet, right, it'd be just a gentle reminder for everyone to join. So let me introduce myself properly first, because I think I influx of a lot of participants just now. So my name is Teacher Chew. I am currently a teacher at Take Academy, giving Math Olympiad courses for upper primary students. So essentially what is RIPM? That probably offer them a spot if they are offer a spot in RI through DSA scheme. If they are able to do well for these papers. Right, so our resources over here, right, with that Take Academy, that we also actually provide you all with a lot of resources which can be found in our WhatsApp group chat. So if you are still not in our WhatsApp group chat already, right, make sure to contact us through this account and join us and ask for the details over here. Okay, so on top of that, right, Teacher Chu is also going to be giving out a short-term course, Take Academy short-term course, to prepare anyone who is joining the RIPMWC. So we are going to go through pretty challenging questions like this one, these ones over here, so that everyone can be a little bit better prepared. Right, more details in takeacademy.sg, alright, .com, I think .com. Alright, so without further ado, hello everyone. I hope everyone is doing well today. Okay, without further ado, let us begin on the first question. I assume everybody has a PDF already. No way, I will casually assume everyone has a PDF already. So let's begin. So we need to find the value of this pretty evil looking expression. Right, it looks really bad. Right, so we have 1 times 2 times 3 plus 3 times 6 times 9 plus 2 times 4 times 7 plus 7 times 14 times 21. Okay, all the way. Then we have 1 times 3 times 5, 3 times 9 times 15. Whoa, it's pretty bad. Alright, it looks really long. Well, what if I told you guys there's actually a pretty fast way of doing this question? Well, but of course, from a student's perspective, right, they might be looking at a different way. We might want to try and factorize things out. Do you guys notice things like, for example, we have 1 times 2 times 3 over here, and then we have 3 times 6 times 9, right? This one will kind of give us a hint. Hey, maybe we can try and factorize out because all of them looks like multiples of 3, right? So that might give us a little bit of hint. But after that, right, you notice that it becomes very erratic, right? Because 2 times 4 times 7, which doesn't fit the pattern at all. So factorizing is definitely out of the question. So what are we going to do in this case? Well, we can look at terms individually. We can look at the denominator and numerator individually. Alright, so let's take a look at 1 times 2 times 3 and 1 times 3 times 5. Alright, and then we can also look at 3 times 6 times 9 and 3 times 9 times 15. Alright, so let's try and simplify them individually first. We notice that 1 times 2 times 3, right, divided by 1 times 3 times 5. Actually, by cancelling out, alright, we're just going to do a little quick cancellation over here. We're just going to get 2 out of 5. Alright, sounds okay so far. Now, what about this? 3 times 6 times 9. Alright, 3 times 6 times 9. And then we have 3 times 9 times 15. Alright, we are going to obtain 6 out of 15. Alright, which casually simplifies down to 2 out of 5 as well. Alright, so there seems to be a little bit of pattern over here. There seems to be a little bit of a pattern that's going on over here. And we're going to keep trying this out. Alright, so maybe we are going to get something out of it. Alright, we have 2 times 4 times 7 over 4 times 5 times 7. Hey, very nice. Alright, we have a lot of cancellation that's going on over here as well. We are going to obtain 2 out of 5 as well. Okay, then what about the fourth one? We have a 14 times 21. Times 7. Alright, we have 7 times 14 times 21 divided by 7 times 21 times 35. Alright, more cancellations up ahead. We have 14 out of 35. Alright, which is equal to 2 out of 5 as well, right? When we divide by 7. Okay, looks really nice. What about last one? 3 times 4 times 67 divided by 2 times 5 times 201. Alright, so maybe you can do a little bit of cancellation over here. So we are going to try to simplify a little bit of things. Cancel the 2. 2 over here. So the rest over here, we are just going to simplify a little bit more. 3 times 2 times 67 over 5 times 201. Alright, so also just nice, right? We simplify this a little bit further. We are going to get 205 as well. We are also going to get 205 as well. So in this case over here, hey, there seems to be a little bit of pattern that's going on over here. And guess what? We have a little helpful thing that can actually help us out. What do I mean by this? Now, we have if we have 4 numbers, right? A over B equals C over D. Alright, then A over B equals C over D equal A plus C over B plus D. That's the critical idea that I want to bring everyone about over here. So the proof is generally pretty straightforward. We can actually, if 2 fractions are equivalent themselves, we can actually rewrite this as Ka over Kb, right? Yeah. So that is essentially the idea. How do we prove this? But we are going to apply this. We are going to look at how do we apply this over here. In this case over here, we notice that everything is 2 over 5. Well, so based on our little theorem over here, we can immediately see that the final answer is just going to be something like that, right? 2 plus 2 plus 2 plus 2, right? 5 plus 5 plus 5 plus 5 plus 5. And guess what? This one is going to give us like 5 times 2 over 5 times 5. Right? Cancelling, right? We cancel 5 over here. Then get a final answer of 2 out of 5. Alright, so I hope this one is really good. Alright, nice to see everyone over here, quite lively in the chat. Alright, so I hope everyone can understand this. Alright, without further ado, I will move on. Alright, so it gets really straightforward, right? You notice that the questions over here look really complex, but after you actually try and simplify and identify some sort of pattern over here, you can actually simplify that and the answer actually looks very elegant. Right, so let's move on to the next question. Hey, hi, Sing. Relax. Okay, let's move on to the next question over here, alright? Now, this one, alright? So it looks really complex again, alright? So we have 1 plus half plus 1/3 all the way to plus 1 over 8 multiplied by half plus 1/3 all the way to 1 over 9. Alright, and then we have this minus 1 plus half plus 1/3 all the way to 1 over 9 multiplied by half times 1/3 all the way to 1 over 8. Alright, looks a little bit on the complex side, right? Looks a little bit complex, but as usual, we can actually simplify a lot of things over here. Now, you notice one very important thing about this question, right, is that we have a lot of repeats. Right, there are a lot of repeats of the same thing. You notice that we have things like, for example, we have things like half, 1/3 all the way to 1/8 repeating itself, right? Except that one of them has a 1 at the front. Alright, we also have another repeat over here, which is half, 1/3 all the way to 1 over 9. Right, which keeps on repeating itself. So why not, right? We use a little bit of algebra to help us out. Simplify it. Right, we are going to let A be half plus 1/3 all the way to 1 over 8. Alright, this is just going to simplify things. You are going to make a complex looking expression look easier. Easy for us to manipulate. That is the whole idea over here. Now what about B? Well, in this case over here, we can let it be half all the way to 1 over 9. Alright, so that's the main concept that I want to bring everyone about. Alright, we can simplify a lot of things through the help of algebra. Because at the end of the day, think about it. Half plus 1/3 all the way to plus 1 over 8. It's just a number. But if I'm lazy to simplify or calculate this number, I can actually let it be some variable in this case. Alright, in this case, I let it be A, I let it be B, etc. So with that, right, we are going to simplify a little bit. Alright, so this one, right, 1 plus A, right, and multiply by B. And afterwards, you are going to have 1 minus 1 plus B. Alright, multiply by A. Alright, so I hope everyone can see this little pattern over here. Now, so after that, right, we are going to apply this thing called the rainbow method. Alright, so A math yes, definitely. Teacher Chu has been teaching A math for like the past 5 years, I guess. Alright, yeah, so so in this case, right, over here, what we are going to do, right, is that we are going to apply the rainbow method, right? Apply the rainbow method. Alright, rainbow method over here. Right, expansion. Alright, so in this case over here, when we apply the rainbow method over here, we can actually expand out, expand all these terms over here. We are going to obtain this really nice expression over here. 1 plus AB. Alright. Minus A. Minus AB. Okay, so really nice. It looks really nice. We have a plus AB over here and minus AB over here. We completely removed the need to find out what is A and B. What is A multiplied by B? Alright, we all can see that A plus B itself, right, is going to be very difficult for us to evaluate, right? This harmonic series over here. As far as I remember, I don't think there was a closed form, right? If anyone remembers a closed form solution for a harmonic series, let me know, alright? Yeah, teacher Chu kind of forgot about it. Alright, so we have B minus A over here. And then afterwards, what is B minus A? Well, we look carefully over here. B has half all the way to 1 over 9. And A has half all the way to 1 over 8. So, in this case over here, what we can tell, this one will just be equal to 1 over 9. Alright, that is the concept that teacher Chu wants to bring everyone across, that we can use algebra to simplify the concepts over here. And it's going to be very, very helpful for RIPMWC. Alright? So, anyone has any questions? No? Yes? Alright, let teacher Chu move on. Alright, let's move on to question 3. Okay? Alright. So we'll find the value of another very complex expression again. Alright, then I hope everyone noticed, right, that whenever we have these long expressions over here, there's always some sort of a trick. Right, and this trick over here relies on the use of the factorial notation and a little bit of A-level concept actually. Yeah, so there's this thing called telescoping series, which is very common in which is a standard topic in H2 math. But we are actually testing in RIPMWC. Surprise, right? Yeah, so in this case over here, let's take a look at this pattern. Find the value of this expression. 2 factorial times 4 minus 3 factorial times 5 plus 4 factorial times 6 minus 5 factorial times 7. Alright, so we can see a pattern over here. It's kind of alternating, right? There's a little bit of minus, there's a little bit of plus, minus, right? It's a very nice alternating series. Now, so in this case over here, right, how are we supposed to work on this question? Well, we'll generally try and find what's the nth term, right? We can generally find, in general, what does a pattern look like? Now, well, if you notice this carefully, it's 2 factorial times 4, alright? And this one is 3 factorial times 5. Alright, so maybe if I were to have some sort of nth term over here, it's going to be n factorial multiplied by n plus 2. That's the idea. Alright, we'll identify the nth term. Alright, that's the whole concept behind this. Identify the nth term. Then we will try and manipulate this a little bit. Okay, so n factorial multiplied by n plus 2. How are we going to simplify this? Is there a way for us to make it easier looking, right? So in this case over here, yes, there is a way. Now we are going to exploit this nice property about factorials, right? So in this case over here, one very important property about factorials is that it's recursive. Alright, this one itself is really n plus 1 multiplied by n minus 1 multiply all the way down to 3 times 2 times 1, right? But then remember, based on definition of factorial, if I were to just multiply all the way from 1 to n, it's going to be n factorial based on our definition. So we can actually simplify this into n plus 1 multiplied by n factorial. That is essentially the idea behind this question. We can actually simplify this a little bit. So how are we going to simplify this n factorial n plus 2? Well, like what teacher Chu will always tell his students, if the expression doesn't suit you, you always massage until you get the expression that you want, and you can manipulate from there onwards. So let's take a look carefully. n factorial multiply n plus 2. This is going to give me n factorial, right? n plus 1 plus 1. Right? This is how teacher will massage out the n plus 1 term. And then afterwards, I'm going to apply the rainbow method. Alright, I'm going to apply the rainbow method inside. Alright, I'm going to obtain n factorial multiplied by n plus 1 plus n factorial. But remember, what is this? N factorial multiplied by n plus 1. Based on what I mentioned to you guys, this is really just n plus 1 factorial plus n factorial. So, we've converted multiplication into sums. That's the whole idea behind this. We've converted all these multiplicative terms into sum of two different terms. Alright, so we are going to apply a little bit, or we are going to apply this formula into this expression and see what we actually obtain. Alright, so we are going to look at this carefully. Now, based on this, 2 factorial multiplied by 4. Alright, what is this going to be equal to? Well, based on our formula, this is going to be 3 factorial plus 2 factorial. Alright, this one is where n is equal to 2, right? What about 3 factorial times 5? Well, 3 factorial times 5 is going to be 4 factorial plus 3 factorial. Alright, this is where the case where n is equal to 3. Right, and so on and so forth. So we are going to have 4 factorial multiplied by 6. This is going to give me 5 factorial plus 4 factorial. Alright, this is n equal to 4. Alright, so in this case over here, we notice some sort of a pattern. Alright, there seems to be some sort of a cancellation that's going on over here, right? You guys notice a little bit more carefully, alright? It can cancel out diagonally. Looks like they can cancel out. But how do we verify it? It doesn't look like we can cancel it out. Well, this is where the alternating series comes in, right? There's a little minus sign over here. Alright, so we're going to write out the whole expression. Now. Alright, you notice that there's some sort of pattern that's going on over here. And it's going to end all the way. Alright, so we are going to write out the second last term and the last term. So we have 2011 factorial multiplied by 2013, right? This one is going to give me 2012 factorial plus 2011 factorial. This is where n is equal to 2011, right? The other side over here will distribute a lot. So in this case, we are going to write minus 4 factorial minus 3 factorial. And then we'll move on to plus, right? Plus 5 factorial plus 4 factorial. You guys can see where the pattern is going, alright? It's going to be minus 6 factorial minus 5 factorial. Alright, so we can see a pattern that's displaying itself over here. Then we'll move on to the next, to the last few parts over here. 2011 factorial, alright, this one is a plus 2010 factorial minus 2012 factorial minus 2011 factorial. Then finally we'll add a 2012 factorial at the end. Well, we notice something over here. Well, in this case over here, there's a little bit of nice cancellation that's going on, right? This is what we call a telescoping series, and we are applying the method of difference. Why? You'll notice there's a 3 factorial and there's a minus 3 factorial. There's a minus 4 factorial and 4 factorial. They kind of cancel each other out, right? So you can follow this nice pattern over here. And you can proceed to cancel everything off. And then you notice, right, the sum over here at the end of the day will just be equal to 2 factorial, which is really just equal to 2. Here you can actually kind of suspect that this is actually from RIPMWC 2015 paper. Yeah, so this is how usually examiners will usually set their papers at RIPMWC. Yeah, they always have the number. So you can expect something along the lines of 2023 to actually appear in this kind of questions for the upcoming round 1 for RIPMWC. So we're going to take a look at this. So this expression, as usual, it looks a little bit scary. But of course, we're going to try and simplify. We're going to try and simplify this as usual. Now, you notice one thing. You can already count suspect, right? 31, 62, 93, etc. All the numbers over there, right? They are going to be multiples of 31. So why not we make life a little bit easy? We factorize them out first. Right? That should be our first strategy when we look at these kind of questions. Right? We can actually we make life a little bit easy. We factorize them out first. Right? That should be our first strategy when we look at these kind of questions. Right? We can actually try and factorize them out first. Now in this case over here, I'm going to factorize out 1 out of 31 for everything over here. Now, how am I going to do it? It's going to be like this, right? So I'm going to take out 1 over 31. Right? And afterwards, I'll take out 1 out of 31. I'll take out the 31 from the denominator, right? So I'm going to be left with 1 over 1 over here. And then I'm going to have 1 over 31 divided by 31 is going to be 1. 62 divided by 31 is going to be 2. Alright, and you can see the pattern that is going on over here. Alright, 1 plus 2 plus 3. Alright, add up all the way to 1 over 1 plus 2 plus 3 plus all the way to 65. Right. Now, so in this case over here, 2015 divided by 31 is 65, I hope. Now, in this case over here, what's next? Well, it looks a little bit off, but remember this really important thing over here. We had learned the sum to nth term, right? So we have this arithmetic progression, all right, with this AP over here, all right, where we have 1 plus 2 plus 3 plus 4, all the way to plus n, right? What's the sum of this expression over here? Well, it's really actually pretty nice, actually. It's actually n plus 1 over 2. So we're going to apply this formula over here because we notice that there are always these sums like this, right? Sum to n term. So we are going to try this out. So we are going to rewrite this expression using that formula out now. 31. Alright, we're going to get 1 over 1 times 2 divided by 2 plus 1 over 2 times 3 over 2 plus 1 over 3 times 4 over 2 plus all the way to 1 over 65 times 66 over 2. Alright, so we can't apply the sums over here now. Now, we have obtained a little bit of fractions over here now. But in this case over here, how are we going to continue? Well, I hope everyone can kind of see that this one is of a form 1 divided by a over b, right? Somewhere along this line. But you guys need to remember that fractions can also be viewed as division as well. So this one is actually equal to 1 divided by a over b. And how do we divide fractions? Well, we always take the reciprocal of it and change the division to multiplication. So it's going to be 1 times b over a. And we're going to end off with b over a. So I'm going to do exactly just that. So this time round, it's going to be 1 over 31. Or 2 times 1 over 1 times 2. Plus 2 over 2 times 3. Plus 2 over 3 times 4. All the way to 2 over 65 times 66. That's a crucial idea that I want to bring everyone about over here. So we can kind of flip the fraction upwards in this case. Now what's next? Well, we notice that there are lots of tools over here, right? There are lots of tools over here. There are lots of really nice tools over here. Maybe we can factorize them out as well. So we're going to factorize out the 2. Alright. So we are going to obtain this very nice and slick expression. Alright. If there are some A-level students over here, by now you should be able to identify this. Alright, we're going to apply partial fractions. Alright, our A math concept to this question now. So in this case over here, let's take a look. Well, this one is actually of a form. Alright, this one is going to be actually of a form 1 over n multiplied by n plus 1. Alright, we are trying to split this fraction up over here. So in this case over here, what teacher Chu is going to do, right, is that I'm going to do a plus n minus n trick. Alright, what do I mean by this? I will take the plus n minus n plus 1. Alright, And then afterwards, I'll split up the fraction, right? I'll split up the fraction into this. Notice that there's some cancellation over here, right? So there's some very nice cancellations over here, alright? And then we actually obtain 1 over n minus 1 over n plus 1. Alright, this is something that is extremely important for Math Olympiad. Alright, so make sure you keep this in mind. Alright, you do not need to know the derivation of it, but it will benefit you a lot if you were to remember this. Alright, it's extremely important. Now, so using this formula, we can actually kind of simplify a lot of things over here. We notice something, right? We have 2 over 31. Alright, I'll write this out. We'll apply our formula. We're going to obtain 1 minus half. And this one is going to be plus half minus 1/3. And this one is going to be plus 1/3 minus 1/4. You guys can see a pattern now, alright? There's some sort of pattern that's going on over here, right? It's going to be very similar to our previous question. Now in this case over here, how are we going to do this? Alright, we are going to do it dot all the way. Plus 1 over 65 minus 1 over 66. Now that's the main idea. And then notice something. Notice that there's a lot of cancellation as usual going on. Right, so the half and half cancels out, right? Another method of difference. Right, so it's going to cancel out. And we are going to be left with just 1 and 1 over 66. That is the idea behind this. So what are we left with? We are left with 2 out of 31. 1 minus 1 out of 66. Alright, this is going to be equal to 2 times 31 multiplied by 65 over 66. Alright, we can simplify a little bit of things. 1 and 33. And your final answer is going to be 65 divided by 1023. Alright, I hope everyone can understand this. This one is a little bit challenging. Alright, so you notice that cancellations will almost always occur in a lot of RIPMWC papers. Alright, and splitting fractions, aka doing partial fractions, is going to be a very useful concept for students to master. Alright, typically we teach this at A-Math, but unfortunately these are the simpler ones over here. We will actually teach them in our Think Academy courses. Alright, so keep that in mind. Alright, let's move on to the next question over here. Alright. Okay, this one looks like another very intimidating expression. Okay, so we need to find the value of 3 minus 6 divided by 1 times 1 plus 2, and then we have 9, 1 plus 2 times 1 plus 2 plus 3, and then we also have 12, 1 plus 2 plus 3, 1 plus times 1 plus 2 plus 3 plus 4, all the way down to 60, right? That's a 60, right? So 60 divided by 1 plus 2 plus all the way to 19 times 1 plus 2 plus all the way to 20, right? Looks very complex. Now this expression itself looks extremely complex. So in this case over here, how are we going to simplify this? Well, actually, if you notice, the numerator itself is something that we can start off with. Right, this is where we can actually start out simplifying this question from. In this case over here, I noticed that the numerator is always a multiple of 3. So why not we try to simplify that first, right? We'll factorize out the 3. I'll pull out the 3. We're going to obtain 1 minus 2 over 1 times 1 plus 2. Alright, and afterwards we have minus 3 over 1 plus 2 multiplied by 1 plus 2 plus 3. Alright. And then we are going to minus all the way. Alright, well, minus all the way to 20. (19) 1 plus 2 all the way to 20. Alright, so doesn't look like it's much, but we notice something over here. This one over here looks like it is of a form, it is of another form again. And this is another form that teacher Chu wants to talk a little bit about. Now, a very important thing over here. So teacher Chu is going to put exclamation mark. So we already know that 1 over n multiplied by n plus 1 is equal to 1 over n minus 1 over n plus 1 over here. Alright? But what about this? What about 1 over n plus k? Right? Is there a way for us to simplify this? Well, in this case, yes, we also have a way to simplify this. This one is actually really nice. I really like this a lot. This one is just going to be 1 over k, 1 over n minus 1 over n plus k. Right? So this one is going to imply that k over n multiplied by n plus k is going to be 1 over n minus 1 over n plus k. That's a crucial idea that I want to bring everyone about over here. So there is also a way for us to do partial fractions, even if it's not n multiplied by n plus 1, but rather it can be n multiplied by n plus k as well. So that's the idea that I want to bring everyone about. So this one over here, it can be applied on the same. It can be we can use the same trick that I've used earlier, and you can derive the expression easily as well, which is a plus n minus n trick, right? So we're going to apply this, alright? So this is something that we're going to apply. Now notice that things like, for example, 2 over 1 times 1 plus 2. Alright, they can actually be separated. You notice that it can actually become 1 minus 1 over 1 times 1 plus 2, 1 plus 2. Right, based on our formula over here, right, 1 plus 2. Now, so we're going to apply this very nice formula to actually help us out. That's the idea. So, if we want to expand this formula out, we are going to obtain a very long expression, right? So 3. I'll keep the 1 as it is, minus 1 minus 1 over 1 plus 2. And then we'll minus again 1 over 1 plus 2, which is our n this time round, minus 1 over 1 plus 2 plus 3. And we're going to minus all the way. Alright, minus all the way down. We are going to obtain the final term over here, which is 1 over 1 plus 2 plus all the way to 19 minus 1 over 1 plus 2 plus all the way to 20. Okay, so that's the idea that I want to bring everyone about over here. In this case over here, we can actually break up the fractions, right? Because you notice that there's always a 2 over here, there's always an extra 2 over here, 3, right? Then we have 20, there are 20, and the rest are all the same, right? The rest are all the same. Which really fits what I have actually defined over here. So we are just really applying this formula. And really just applying this formula onto the expression itself. And notice that, hey, there's also a lot of cancellation that's going on over here. But be very careful. Alright, this one is minus and then there's a bracket over here. So minus is plus, right? Negative number multiplied by negative number is a positive number. And of course, negative number, when we divide negative numbers, we also have this minus plus rule as well, right? Now, so in this case, we notice that there's actually quite a bit of cancellation because this one is a plus now, right? The minus goes in for the whole bracket, right? This one becomes a minus. We can't cancel a lot of things over here, in fact. Alright, be very careful. The minus distributes as well. So we're going to be left with this. We're going to be left with 3 multiplied by 1 over all the way to 20. Alright, then we remember our Gaussian sum just now, right? Alright, so yeah, this one is not math. This one is not primary school math, alright? I mean, this one is primary school kind of math, but this one is primary school math Olympiad, alright? So don't worry too much, alright? If you are not going to learn this, you're probably going to learn this in A levels properly, alright? Now, so we remember our sum over here. This one is actually 3 multiplied by 1 over 20 times 21 over 2. Right, we're going to obtain a final answer of 3 out of 210, which simplifies down to 1 over 70. That's the crucial idea that Teacher Chu wants to bring everyone about. You notice that the same concepts repeat themselves over and over again. The method of difference, partial fractions, alright, and our standard arithmetic progression sums. They're going to appear over and over again in our RIPMWC. Alright, so I hope everyone has learned a few little bit of tips and tricks over here. And let's move on to the next question. Alright, so finally we do not really have a calculation question anymore. Instead, now we have a little bit of word problems. Alright, so let's take a look at what this word problem is about. So we have three little sheep. They are erecting a fence, right, to keep the nasty wolves away. Right, so we have a little bit of information. The first two sheep working together could erect the fence in 2 hours. Right, so the first two sheep, or first and third sheep. Right, first and third sheep could erect the fence in 1 hour and 12 minutes. Or second and third sheep. Second and third sheep could complete the job, alright, in 1 hour and 30 minutes. Right, so how long will it take for the second sheep alone? You just need a second sheep alone this time to complete the job. Right, so it looks like a very, very complex word problem. But actually, we have secretly 3 variables that are unknown. We actually have secretly 3 variables that are unknown. We do not know how fast can the first sheep work alone to erect the fence. We do not know how fast can a second sheep work alone to erect the fence. We do not know how fast the third sheep alone can erect the fence. So in this case over here, it's a little bit complex. So we're going to employ the help of algebra to help us out. So in this case over here, we are going to let x, alright, we are going to look at time in minutes, alright, time in minutes. Why minutes? Because we have things like 1 hour and 12 minutes, right? If we have to convert it into hours, it's going to look a little bit complex. So we are going to look at time in minutes to complete the job alone. X is the first sheep, alright? So the first sheep is going to take X minutes. Alright, what about Y? Y will be the second sheep. And Z is going to be the third sheep. Alright, so let's look at this a little bit carefully, alright? So we know that for the first sheep, for example, he needs X minutes equal to 1 fence. Right, so what about 1 minute? How much of a fence can he build in 1 minute? Well, we can just divide by X, right? So 1 minute, right, he can build 1 over X of a fence. So I hope everyone can see some sort of pattern over here. You know the fence. And this one is going to be equal 1, right? This one is going to be equal 1. And if I were to shift the 120 downwards, I'll get 1 over X plus 1 over Y equal 1 out of 120. Oh, so there's actually some sort of pattern that's going on over here, right? I hope everyone can see the particular pattern that is exhibited over here in this question. So we're going to apply our similar methods over here. Now, in this case over here, what's next? We notice that the first and third sheep working together can erect a fence in 72 minutes, right? This one is 72 minutes. Alright, this one is 72 minutes over here. So, in this case over here, following our pattern, we can see that 1 over X plus 1 over Z is equal to 1 over 72. Okay, what about the last one? Alright, the last one is just going to be 1 over Y plus 1 over Z equal to 1 out of 60. Alright, because the... Oh, my bad. Sorry, 90. Alright. Yep, so this one is a P6 Math Olympiad, but we also have P4 or P5 joining as well, RIPMWC, alright? Now, in this case over here, we have 3 equations, right? We have 3 equations. We have the first equation, alright, we have 1, 2, we have 3. What's our objective? Our objective is to find the value of Y, right? Find y, right? Because we are asking for how long will it take for the second ship alone to complete the job. Well, how are we going to do this? Well, you notice something, right? We actually have, if I were to add up all these equations together, right, what am I going to get? I'm going to get two sets of 1 over x plus 1 over y plus 1 over z. Alright? This one is going to be 1 out of 120 plus 1 out of 72 plus 1 out of 90. Alright, this one is going to give me 1 out of 30. Alright, and then what's next? Well, in this case over here, we can actually look out for what is 1 over x plus 1 over y and 1 plus 1 over z. In this case over here, 1 over x plus 1 over y plus 1 over z is going to be equal to 1 over 60. And then notice something, we actually need 1 over y. We can find out what is 1 over y. But we know that 1 over x plus 1 over z is equal to 1 over 72. So we can kind of find 1 over y is 1, right? So 1 over y is equal to 1 over 60 minus 1 over 72, which is equal to 1 over 360. And this will mean that y is equal to 360. So in this case, the second sheet is going to take 360 minutes to complete this job. Alright, so these are some standard rate problems. Alright, standard rate problems. We really rely on this concept. Alright, this is the biggest concept that everyone needs to remember. Alright, when we take X minutes for a particular job or offense, in 1 minute, you're going to build up 1 over X of a job or 1 over X of a fence. That's the crucial idea that teacher wants to bring everyone about for this question. Alright, with this concept over here, you should be able to derive all these really nice equations out yourself and try to simplify them. Alright, in fact, you can actually find out X and Z as well using this trick. Alright, so maybe a little bit of exercise, maybe you guys can actually figure out what is X and Z. Alright, so there are no questions over here. Let us move on to the last question for today's DMD. Alright, so we have one last question over here. Okay, so another word problem. Alright, looks a little bit complex. So let's talk a little bit about it. So with Ali and Brian, they left town A, alright, at the same time for town B. Alright, so that's the idea. Now they are 25 kilometers away from town A. So we have Ali started riding a bicycle at 8 kilometers per hour, and he parked the bicycle at a cycle station and walked at 5 kilometers per hour for the rest of the journey. And then Brian set out walking at 4 kilometers per hour. He reached the cycle station and he used the bicycle, alright, by Ali, and rode at 10 kilometers per hour. And both Ali and Brian reached town B at the same time. For how many minutes the bicycle was not in motion? Alright, so this question is a little bit complex. Alright, so maybe it will help us if we draw out and visualize it out ourselves. So, notice one thing, there are two towns. Alright, why not draw a little timeline out over here? Alright, there are two nice towns over here. Alright, look at A, this is town A, this is town B. We know that the total over here is 22.5. Right, total over here is 22.5. Okay, what's next? Well, we know that there's a cycle station, and the cycle station is going to be fixed, right? Maybe the cycle station is here, I don't know. Maybe a cycle station is here, right? Station. Alright, and then we have two guys over here. We have Ali and Brian. Alright, how are they going to do it? Alright, Ali is going to cycle here. And what's the speed over here? He is going to ride the bicycle at 8 kilometers per hour. And afterwards, he's going to walk. Right? He's going to walk afterwards. He's going to walk at 5 kilometers per hour. And what's next? Now, in this case, let's take a look at Brian now. Brian, he's going to start walking. So start walking over here at 4 kilometers per hour, right? And he's going to cycle after that. He's going to pick up the bicycle. That was left at the station, and he's going to cycle at 10 kilometers per hour. Alright, so we can actually condense the question into a really nice diagram. Alright, so there are all the useful information over here. Alright, now what's our question? Our question is for how long the bicycle is not in motion. So how long was the bicycle left there before Brian actually uses it? Okay, so how are we going to work on this question? Now in this case over here, of course there's going to be a little bit of algebra that we are going to apply. How about this? Why not we let this be x, right? Let the distance be x. Alright, between the station and town B, let it be x. Now in this case over here, so naturally, you can see that this one is actually 22.5 minus x. Alright, and then we remember our speed, distance, time diagram over here, alright? Our distance, speed, time diagram over here. So d, s, and t, right? Distance divided by speed is time, distance divided by time is speed, and speed times time equal to distance. Alright, so we're going to apply this, right? These are all distances, right? These are all distance over here. What are we going to do? Well, in this case over here, we're going to exploit this fact over here. Both Ali and Brian reach town B at the same time. Alright, so let's take a look at time taken by Ali. What's time taken by Ali? Well, we have the speed, we have the distance as well. So, distance divided by speed gives us time, right? So, in this case over here, we can see that it is distance, 22.5 minus x, divided by 8, plus x divided by 5. That's the time taken that is the time taken by Ali. Now, what about the time taken by Brian, right? Time taken by Brian. Alright, this one is going to be the same logic. Alright, we're going to walk first, 22.5 plus x over 4 plus x over 10. But remember what we actually said. The time taken is equal. So both of them must be equal, right? Alright, so we're going to have this very complex looking expression over here. We are going to write it out nicely. Right, so 10. Alright, plus 22.5 minus x over 4. Go to x over 5 plus 22.5 minus x over 8. Okay, so how are we going to do this? How are we going to carry out or simplify this over here? Well, notice something over here, right? In this case over here, if you look at the denominators a bit closely, this one is a 5 and this one is a 10. Alright, and then this one is a 4 and this one is a 8. Well, let us take a look and try to simplify this together. Alright, so we are going to move the terms over here. 22.5 minus x over 4 minus 0.5 minus x over 8. Right, this one is going to give us x over 5 minus x over 10. Now, in this case over here, we need to make the denominators the same. So, this one is going to give me 22.5 minus x minus 22.5 minus x over 8 equal to 2x minus x over 10. And then you notice that there's a lot of simplification that we can actually work on, right? So this one is going to give us just 22.5 minus x over 8 equal to x over 10. Right, we can cross multiply that afterwards, right? When cross multiply, make sure to multiply the numbers properly. Well, we get 10 22.5 minus x equal to 8x. This one is going to give us 225 minus 10x equal 8x. Subsequently, 18x equal to 225. And hence, x is really equal to 12.5. Okay, so we obtained 12.5. Alright, but so in this case over here, we know that the distance over here is 12.5. And the distance over here is really just 10. Okay, great. But is that the end? No, that's not the end. In this case over here, we need to find out and figure out how long was the bicycle not in motion. Well, you guys think about it. He parks the bicycle over here. And he continues to walk. So how long did he actually take over here? Right, so the time taken over here, the time in this case, is really distance divided by speed, right? So the distance we know is 12.5, and speed is 5. Right? He is going to take 2.5 hours. Alright? So a bicycle can mostly not use for 2.5 hours. But then how long did he take to cycle? How long did Brian take to cycle? He actually took time 12.5 over 10, which is equal to 1.25 hours. So the difference must be must be due to the fact that the bicycle was not in motion. So in this case over here, what's the difference? The difference, alright, bicycle not in motion is equal to 2.5 minus 1.25 hours. And that's the idea of solving this question. Looks very complex, looks extremely difficult. In fact, it uses a lot of concepts from secondary school math, solving linear equations. So in this case over here, I hope everyone can actually appreciate it and be able to apply the diagram method and solve these kind of questions. They are tough, but with the diagram and understanding the distance, speed, time pyramid, is going to help us out a lot, right? You notice that all these rate problems, they generally do actually have a pyramid over here. And with that is pretty much about it. I hope everyone has actually learned something today. So just to share with you guys again, I'm Teacher Chiu, and I'm currently a teacher at Think Academy, and we have a short-term course that's coming up. So if you guys are still are interested, you guys can move on to www.thinkacademy.com and sign up for my short-term course that's incoming for that's preparing you guys for RIPMWC. Alright, with that is pretty much about it. I'll see you around next week. The second week of DMD has been uploaded into our WhatsApp group. If you have not joined our WhatsApp group yet, make sure to join us so that you guys can get the DMD to prepare yourself. Make sure everyone can get the DMD and prepare yourself for next week. Alright, with that, I'll see you around next week, and thank you very much, and have a good night. Alright, question 1. Alright, sure. I'll show question 1. Well, question 1 is a little bit far off. Just give a moment. Right, so there's a very nice pattern over here. Notice that all the terms are actually equal to 2 over 5. Alright, so it's really nice. This question 1 over here is very sleek and nice. So I hope everyone can catch what's going on for this one. There's a very nice important property over here, right? If we have A over B equals C over D, then we have A over B equals C over D equal A plus C over B plus D. Alright, I hope this one is clear. Okay, so make sure to screenshot. Alright, thanks everyone. And I will see everyone for the DMD next. Alright, I'll see everyone next week for the next DMD. Alright, thank you. Have a good night, everyone.